This lesson covers the types of zone configuration and split DNS. DNS is critical to Active Directory, and because of the tight bond between Active Directory and DNS, there are actually a lot of different configuration options for DNS and how we store zones that you don't see on a typical DNS server implementation. After all, DNS is the name locator service for Active Directory. Now, there are two primary types of lookup zone. There are forward lookup zones. So a forward lookup zone takes a name that we give it and returns us an IP address. So for example, I can look in saviltech.net and I can say for iOmega NAS, it returns me 192.168.1.6. A reverse lookup zone, as the name suggests, takes an IP address and gives me the fully qualified domain name. So I can see here all the records. So that same host, 192.168.1.6, would point me to iomeganas.saviltech.net. So there's forward and there's reverse lookup zones. Within there, I have different ways to actually store my zone. If I look at my saviltech.net and look at my properties, we'll see this is Active Directory integrated. So what this means is this zone, all the records, is actually stored in the Active Directory itself. Now, the other type of zone we can actually create is don't store it in the Active Directory. So this is now going to create basically a file. So I'll create a new primary zone. Now, if we aren't storing an Active Directory, we actually can leverage a secondary zone. So a primary zone, think of it as a writable copy of the zone that is stored in a text file. A secondary zone is a copy of that primary zone that helps balance that load. So I'm going to create a primary zone and I'll just give it any name. So maybe I'll say saviltech.co.uk. Actually, a good example, I'm going to use .com. I'm just going to create a file and I can't do dynamic updates because it's not Active Directory integrated. And finish. And on that server, I now see a text file. And this text file contains the records in that zone. So if I go and add a new record, so I'll just say a host record test. And I'll just give it an internal IP address. Add that host, done. If I was to look at that file, that's my zone. So this is storing it in a text file. I could now, if I wished, create a secondary zone on another DNS server just to point to this, to load balance those queries. Note that any changes, though, always happen at the primary server, and then those changes are pulled down to the secondary. Going back to my Active Directory integrated zones, though, I have a number of different options. So if I select change here, I can say to all DNS servers running on domain controllers in the domain, so only replicate this between domain controllers that are running the DNS service for this one domain. You could also say, well, run it to all DNS servers running on domain controllers in the entire forest, or just replicate it to all domain controllers in the domain, regardless of if they're running DNS services or not. And this used to be the only option we could do in Windows 2000. 2003 added the ability to add application partitions in Active Directory, so I could create separate partitions for domain DNS zones and forest DNS zones, which is actually exactly what has happened. So when you select this option to all DNS servers running on domain controllers in the domain, the way this works is it actually stores the data in a separate directory partition. So I'm going to cancel that out, and I'm going to fire up a utility called ADSI edit. So the utility is launched, and it's showing me my default domain. What I'm now going to do is connect to an alternate naming context. So I'm going to connect to domain DNS zones. And the name for this, I'm actually going to type in the full name, is going to be DC equals domain DNS zones, comma DC Saviltech, so the name of your domain, comma DC equals net, so saviltech.net. And now I can actually go and see the records stored in Active Directory for that zone. This is how it's storing it. It's actually storing it as a separate application partition in the Active Directory. Likewise, there's one for forest DNS zones for if a zone is replicated to all domain controllers running DNS in the entire forest, which is the _MS-DCS, because this contains records for things like the global catalogs, FSMA roles, things that are universally needed across the entire forest. So they're my main types of zone. I can have primary, secondary. I can integrate it with Active Directory if it's a primary zone. I can't store secondaries in the Active Directory. And when I store in the Active Directory, I can store it in a separate application partition for all the DCs in the domain that are DNS servers, or just store it in the regular domain partition, which in ADSI edit would just show in the regular default naming context, or I can store it in that forest zone. There is also one other special type of zone. So if I jump over to my second DC, I can create something called a stub zone. What a stub zone does is it just captures the start of authority records for that zone, who are the authoritative DNS servers. So I give it the zone name. So I'm going to say saviltech.com. And I give it a name of one of the servers that's actually hosting that. Now notice what it has. It does not have the same records. It doesn't have that test record because all it's storing are those start of authority and the name servers. So why is this useful? Imagine I'm a very, very large enterprise. Imagine I have saviltech.net and I have saviltech.com and I have subdomains. So maybe I'm sitting in subdomain marketing.northamerica.saviltech.com and a client in that domain asks me for a record in legal.sales.saviltech.net. So that's a long way away in DNS terms. My server would have to do a request up to the northamerica.saviltech.com, then saviltech.com, then com, then down to saviltech.net, then sales.saviltech.net, and then legal. So there's a lot of jumps to be able to find that DNS server that's responsible for that legal.sales.saviltech.net. If I add a stub zone in that saviltech.com subdomain for the legal.sales.saviltech.net, it automatically knows who the DNS servers are. It will automatically replicate over when new name servers are added, when that start of authority changes. So now I can bypass all those hops up and down the DNS hierarchy and basically jump directly to the right name servers. So this is something you would want to use if you did have a very large, complicated namespace in your environment, and I can just add a stub zone. This is very different from a forwarder. Remember, a forwarder would say, well, for saviltech.com, go and talk to this specific DNS server, but it wouldn't dynamically update. It's not sharing and that traffic. So they're doing two very different things. Finally, I wanted to talk about split-brain DNS. Now, in your organization, you're going to have internal DNS services, such as for your Active Directory, so saviltech.net, and you may have external services to your clients. Now, suppose you use the same domain. So I wanted saviltech.net internally, and I wanted saviltech.net externally. Well, I definitely don't want to expose my internal DNS records to the internet. I'd never want to do that. So it means I'd have to have something called split-brain DNS. I'd have a name server on my internal network for my internal saviltech.net records, my Active Directory. Then I would have an external DNS server, maybe my DMZ, to handle those external queries. Now that may sound fine, but it can get very complicated. So imagine the scenario, which is what I was setting up in this environment right here. Now normally I could just say nslookup www.saviltech.com. So it would be my external website. But it's failing. The reason is, well, I've got a split-brain DNS. There's a web server on the internet for saviltech.com, but because I also created that zone internally, maybe I'm using it for my Active Directory, that's who I'm asking, and it doesn't have a record. Now, I could absolutely go and I could say create www.saviltech.com, and I could point it to that test server I created. And now if I do that nslookup, it's going to work. But this is the problem with split-brain DNS. For all the people internal to your organization, for any record you want them to be able to resolve to that outside world, you're going to have to duplicate it on that internal zone, which is a lot of work. Really, unless you have to, you don't want to do this. I do not want this split-brain, so I'm actually going to delete that. So now if I did that same lookup again, I actually get pointed to the correct server out on the internet. So what should you do? Use a subdomain. If your external name is saviltech.com, you could use ad.saviltech.com for your Active Directory. Other companies buy things like the .NET version. So they might use saviltech.net for the internal Active Directory so it doesn't clash with the external DNS servers. And that's actually something I do in my lab environment. So it's just something to definitely configure when you're thinking about your DNS. How do you want to organize this? How do you want to use it? And you may well have subdomains. You might have a northamerica.saviltech.net with its own set of DNS servers. And what would happen is essentially in saviltech.net, it would actually do something called a delegation. So you would delegate a part of the namespace such as North America, and you're going to point it to which servers host that namespace. Now in Active Directory, if you just create a new subdomain and it has its own DNS servers, the delegation happens for you automatically. But if you ever needed to do it manually, maybe it's a separate complete forest or not even Windows portion of the namespace, that's how you say, hey, these servers are authoritative for this portion of the namespace. This concludes the lesson on zone configuration types and split DNS.